Now let's understand the number of elements in sets using the properties. If A, B and C are finite sets, that means the number of elements are countable, and epsilon denotes the universal finite set, that means universal set is also finite, then the first property is number of elements in A union B is equal to number of elements in set A plus number of elements in set B minus number of elements which are in both set A and B, which are common. Okay, so how do we see, or how do we understand it using Venn diagram? Let us try to find out. So let us suppose this rectangle, it is our universal set. So we have here set A and then we have set B. Okay, so the area, so the A union B is the set of all elements which are present in set A, set B and in both set A and B. So this denotes A union B. Okay, so A union B. It will be equal to, again let us draw the same Venn diagram. It will be equal to, so we have set A, set B. It will be equal to the number of elements in set A. Okay, so it will be this very region. So let us shade this region. Okay, plus again we have two sets A, B. This is A, this is B. It will be equal to number of elements in set B. Obviously this time we shade this very region. Okay, from that we subtract the common area. Okay, because here you can see in set A we have this very region, in set B we have again this region, so we subtract, and let me try to draw it here. So we have set A, set B, this is set A and set B. Okay, and we subtract this very region from this, then we will get the number of elements A intersection B. Okay, so we can now see number of elements in A union B. So this very shaded region will be equal to the number of elements in set A plus the number of elements in set B minus the common region between A and B, that is A intersection B. Okay, this is the first one. Now let us learn about the second property, that is the number of elements in A union B is equal to number of elements in A plus number of elements in B, which double implies that A and B are disjoint non-void sets. Disjoint means they have no element in common. So let us try to break this out. Let us suppose this is our universal set. We have two sets A and we have B. Now union of A and B will be, so union of A and B will be, so this very region. So it is very pretty simple to see what our result will be. So it will be equal to number of, that is elements present in set A, so it will be equal to NA plus we have set A, set B plus the number of elements present in set B. So this is straightforward. When this happens, we say the sets are disjoint, they have no element in common. Earlier we had some region common between two sets, this very region, intersecting region. Since there is no common region, so we can say they are disjoint, means they have no element in common, and non-void, they have elements in them. Okay, so this is the second property. Now coming to third property. So number of elements in A minus B, and let me try to draw it here again. So we have two sets. Let us suppose this is set A, then set B. This is our universal set. Number of elements in A minus B. Okay, so let us suppose this is A, this is B. So from from A, when we subtract B, we will get that very region, the region. So this region denotes this is the region of A minus B. So this is the region of A minus B. It will be equal to, let us see here, it will be equal to number of elements in B, the number of elements in A. Again, let us draw it. So we have A, B. It will be equal to the number of elements in A. Okay, so number of elements in A minus, let us draw again, this is A, this is B, number of elements which are common to A and B, there is A intersection B. So A intersection B is this very region. Again, you can see when we A minus B will be equal to number of elements in set A minus the number of elements which are common to A and B. Okay, likewise, if I take shaded region this time this white region in consideration, so you can find out this B minus A by same logic. I will not show it here, so it is very simple also. So we have set A, set B, this time we have B minus A we have to do. So this very region will denote B minus A, and it will be equal to number of elements in B minus the common region, that is, if we have A intersection B, so this region, when we subtract this lens shaped region from this, we will get this, the number of elements in B minus A. Now we will also take some numerical examples or word problems on this.